of pruning in decision tree. So when you take this decision tree, the features which are all not important or can't be taken into account can be done in two ways. One is pre-pruning or another one is a post-pruning. That is, before the start of the construction of the decision tree, if you prune some of the features, then it is called as pre-pruning. Okay, after the construction of the decision tree, if you say these features are not essential, then it is called as post-pruning. Okay, so post-pruning normally will be used when a tree is overfitting. Overfitting in the sense anomalies, duplicates of the rules is coming again and again. Okay, and the tree branches are growing and growing. Then in those cases, this post-pruning will be helping you to remove the attributes which are all not so important for taking the decisions. Okay. So that day we saw naive Bayesian classification method. Okay. In case of this naive Bayesian classification, we have done with two problems. One for the categorical values, another one for the numerical values. Yes or no? For the categorical, the normal probability method you will be using. But in case of the the numerical value, will be going for the Gaussian density function. We worked out some 2 or 3 problems in this naive Bayesian. And there are here some of the advantages and disadvantages of the naive Bayesian classification. Each and every classification method is having its own advantage and disadvantage. Even in the decision tree also, I told you the advantages and disadvantages. So we will go for some training and then for testing. So the training set will spend some time in case of the decision tree and will make the decision tree and the rules will be extracted. But in case of the naive Bayesian, we won't do in that manner. When test data is coming in that place, we will be applying that formula and will classify the particular sample. Okay, so here also several disadvantages available. Okay, so what is the advantage and the disadvantage of the naive Bayesian classification? See, first of all, it is easy to implement. Yes, it's only of simple probability technique, so it is very easy to implement. And in most of the cases, okay, the results are good. Okay, but when there are dependencies on attributes, then in those cases, some loss in accuracy will be taking place in the classification of this naive Bayesian approach. What is this class dependency? For example, one attribute is depending on the result of another attribute, then it is considered as what? The dependency. So, if multiple attributes are depending on each other, in those cases, this naive Bayesian classification will not give or yield a good result. In those cases, the solution is the Bayesian belief networks. Okay. So, புரியுதா நம்ம ஏன் வந்து Bayesian belief network போறோம்னு சொல்லி இப்போ ஒரு particular attribute இருக்கு. For example, that is a test result. For example, when a person is having some breathing problem, but this is one attribute, breathing problem, yes or no, that attribute will be there. We will have one more attribute called as smoking. Okay, if smoking is yes, then breathing problem will be yes. This is actually a class dependency. Because of smoking only, he is having this breathing problem. This is actually a dependency between these two classes. If these kinds of dependencies are available in the given data set, then this naive Bayesian classification will not give us some accurate results. In those cases only, we are going for this Bayesian belief networks. புரியுதா? Yes? புரியுதா பசங்களா? ஏன் வந்து நம்ம Bayesian belief network போறோம்ட்டு? ஏதாவது எஸ் நோ ஏதாவது சொல்லு.
Yes, ma'am.
Remaining? Satyavardhan? What happened? Okay, thank you, Shalini. So this is the reason why we are just moving to this Bayesian belief network. So there are multiple names for this Bayesian belief networks, Bayesian networks, probabilistic networks. Okay, probabilistic networks are Bayesian belief network because conditional probability and joint probabilities we are going to use here. That's why this is considered as probabilistic network also. Okay. So normally this belief networks specified by joint probability conditions. Okay. So in the joint probability conditions, probability, இதெல்லாம் வந்து புரியலனாலும் பரவாயில்ல. If you work out the problem, then it will be clear. The Bayesian belief networks can be defined by using two conditions. One by using DAG, another one is set of conditional probability table. What is DAG? What is DAG, ma? DAG is directed. D is directed, G is graph. அப்படின்னா DAG னா என்ன?
Acyclic graph.
Yes, it is a directed acyclic graph. Okay, so this joint probability conditions or this Bayesian belief network can be defined by using these two. One is the directed acyclic graph, another one is a set of conditional probability table. So let's see the example for this DAG. DAG is a directed acyclic graph. See this directed acyclic graph. Observe this and tell me what it is. Which one is the class label in this? See, these are all some of the attributes of the table. The attributes were given in the format of a directed acyclic graph. Tell me which one is the class label over here. Whether the patient is affected by lung cancer or not. Yes or no? There are several reasons for that lung cancer. Family history, he may be a smoker, and emphysema is nothing but some breathing problem. Okay. Okay, it's a kind of damage of or because of this some damage in the lung wall. I hope it is. Dyspnea is the breathing problem. Okay. Emphysema is the damage in the lung of the wall. I mean wall of the lung. If he is a smoker, then this emphysema will come. And also he may get a chance of this lung cancer. So again, one more thing is also there called as dyspnea. Dyspnea is a breathing problem. Okay, and there is a positive X-ray. If the X-ray result is positive, uh, because of this lung cancer. So this is actually directed acyclic graph. It will have what parents. For example, these are all the results of a particular attribute. So each and every node is actually a result. Okay. So if you see this conditional probability table, so what is the probability of a person which is having lung cancer and family history and is a smoker? The probability of getting lung cancer is 0.8. Okay, so the probability of getting lung cancer when he is having this family history and not a smoker, in the sense it is 0.5. So some numbers were given, and these are all the probabilities. Okay, so here lung cancer is actually the class label. So the probability of getting lung cancer and not getting lung cancer is given over here. So normally when you see this conditional probability table for a variable y in the sense here it is what this LC. It specifies the conditional distribution. So this can be given as P of Y, the conditional probability, the parents of Y. So this lung cancer is depending on what this family history as well as the smoker. So this is one of the conditional probability. So the percentage of getting the lung cancer is depending on the family history and the smoker. If this condition exists, the Bayesian classification won't work accurately. Okay, that's why we are just going for this Bayesian belief network. Okay, right. So this, if you see this DAG, So a node Y is there and node Z, for example, lung cancer to dyspnea. So node Y to node J. இந்த மாதிரி ஒன்று இருந்ததுன்னா, so in this cases, this arrow mark is representing that Y is the parent or the predecessor of Z, and Z is the descendant of Y, we can say. Yes, it is the thing. And each and every node in this network can be specified as the output node. Sometimes more than one node may be considered as what this output node. Okay, let's see how we are going to train this Bayesian belief networks. So just leave all this formula. When you're just going for this problem, you will be understanding it. Okay, see this problem. Okay, the probability of getting rain, okay, is depending on two features when it is windy and cloudy. Okay, so since windy and cloudy are not having parents, it is having only what the normal probability. Okay, but when you see this wet grass after rain, the probability of the wet grass and take off from work, okay, just leaving from work, those probabilities were given here. When you see the probability table, the windy and cloudy are not depending on any of the other features. Therefore, only one label you are observing. That is, probability of windy is 0.001 and the probability of cloudy is 0.002. But when it rains and the probability of getting wet grass is given over here. So if the rain is true, the probability of the wet graph is 0.95. When the rain is false, the probability of wet graph is 0.05. So this is actually conditional probability. Okay. So that's a conditional where when it rains or not rains. Okay. And take off from work, the probability is given over here. When it rains, what is the probability of leaving the work? Okay, when it is true, it is 0.91, and when it is false, it is 0.01. But when you see this rain, it depends on two conditions, windy and cloudy. So all the probabilities we need to judge over here. When both are true, that is both windy and cloudy, what is the probability of getting rain? When it is not windy and not cloudy, what is the probability? When one of the condition is true, then what is the probability we are given here? So these are all some of the conditional conditions, conditional dependence. Okay, so now this DAG is given to you, that is this directed acyclic graph is given to you with some conditions, and the probability table says what are all the probabilities we are having. And they are asking one thing called as what is the probability of having a wet grass? Okay, what is the probability of the wet grass they are asking? Let's calculate that probability. The probability of the wet grass, when you see இது நீங்க ஃபார்முலாலாம் பார்க்க வேண்டாம். So probability of getting wet grass depends on two things: when it rains or it is not raining. Yes or no? Hey, all are listening to the class? All are listening or not?
Yes, ma'am.
So இது வரைக்கும் நான் என்ன சொன்ன சொல்லி பார்க்கலாம். Can anyone summarize what I told till now? Why we are going for this Bayesian belief network? Anyone, please.
To overcome the disadvantages of the naive Bayesian classification,
Okay.
as it has larger dependencies.
Yes, when there are class dependencies, then Bayesian belief network is the solution. Okay. So Bayesian belief network is depending on the conditional probability. Formula ve idha. Conditional probability, joint probability. These two things we are going to consider in case of what this Bayesian belief network. It is defined by two things. What are all they? What are all they? See, Bayesian belief networks are defined by two things. What are all they? ரெண்டு விஷயம் வச்சு நான் Bayesian belief network சொல்லலாம்னு சொன்னேன். என்னது அது?
Directed acyclic graph.
One is the directed acyclic graph, another one is the probability. அவ்வளவுதான். So listen here, this is a directed acyclic graph, right? A graph which contains nodes Each and every node is actually an attribute. Okay, and in that attribute we are having what several class labels also, and sometimes one label, sometimes two labels, multiple labels you can take. So the probabilities will be given over here, and the output or the Bayesian belief networks can be given in the form of joint and the conditional probability. Okay, இந்த ரெண்டு ஒன்னு DAG and probabilities வச்சு சொல்றோம். Probability ல again two things coming. One is a joint probability, another one is a conditional probability. See, the probability of getting rain is depending on two conditions, weather and windy and then cloudy. This is actually what the conditional probability. I'll say what is this joint probability afterwards. Let's see this formula. So they are asking what is the probability of having a wet grass. So என்ன probability இருக்கலாம் அப்படின்னு கேக்குறாங்க. So the probability of the wet grass depending on two conditions, whether it is raining or it is not raining. Yes or no? ஆமா தானே. உன்னோட probability table of wet grass பாரு. wet grass ஓட probability என்ன கொடுத்திருக்காங்க? Rain true ஆ இருந்தா ஒரு probability, false ஆ இருந்தா ஒரு probability கொடுத்திருக்காங்க. கரெக்ட்டா? ஆமாவா இல்லையா?
Yes, ma'am.
So the probability when it rains and the probability when it is not raining. But when you see this rain is depending on what? Several other factors also. Yes or no? ஆமா தானே. இப்போ இந்த wet grass is depending on this rain, but rain is depending on what? Two more probabilities. What are all they? Windy and cloudy. ஆமா தானே. ஆமாவா இல்லையா?
Yes, ma'am.
இப்போ இது conditional probability. கரெக்டா? Conditional probability நான் already சொல்லிட்டேங்க. ஏன்னா the probability of getting rain depending on these two conditions, so it is a conditional probability. But the probability of getting rain over here is a joint probability. I'll say what it is. அப்படின்னா என்ன? Let's look into this conditions clearly. I'm saying, see, what is the probability of getting rain when the grass is wet? Sorry, wet grass when it is raining. What is the probability? Wet grass when no rain on true. அப்படின்னா probability என்ன?
0.95, ma'am.
0.95. 0.95 into I don't know what is the probability of rain. Okay, that see this probability of getting rain is depending on four factors. Yes or no? See the probability table. ஆமா தானே, 4 ஃபேக்டர் டிபெண்ட் பண்ணி இருக்கு. ஆமா தானே, ஆமாவா இல்லையா? See the probability table of rain. The probability of getting rain depending on two factors. What are all they? What are all they?
Windy and cloudy.
Windy and cloudy. So I have to calculate it separately. So this is nothing but what? The joint probability. இங்க நான் வந்து இந்த joint probability எடுத்துக்கணும். இது condition. So that I will explain separately. Plus, what is the probability of getting wet grass when it is not raining? When it is not raining, what is the probability of getting wet grass? See the table.
0.05.
0.05 is 0.05 into probability of not raining. Okay, not raining, I'm just taking. Let us calculate the probability of the rain. So it is depending on four conditions. What are all they? The probability of getting rain when there is no wind and no cloud. Okay, and then it should be multiplied. This is a conditional probability. And now I'm taking the joint probability of the wind as well as cloud. So again, this should be added with the probability of getting rain when there is no wind, no cloud. This is a conditional probability. And now this is actually a joint probability. Into the probability of not wind. Not wind and not cloud. Plus the third condition, the probability of getting rain and the not windy, cloudy should be multiplied with the joint probability of not windy and cloudy. This should be added with the probability of getting rain of windy and not cloudy with the joint probability of windy and not cloudy. Both are true, both are false, any one of us are true. Okay, புரியுதா? இது conditional probability மா, இது joint probability. இந்த joint probability கண்டுபிடிக்கிறது எப்படின்னு நான் சொல்றேன் இப்ப. So what is the probability of getting rain with W is equal to true and C is equal to true? What is the probability ma? See the probability table. Rain oda probability table பாரு. Both windy and cloudy. True க்கு என்ன probability இருக்கு?
0.95.
0.95. So for this first thing I am just writing. இந்த இதுக்கு நான் எழுதுறேன் இப்போ. Okay, this is 0.95 into what is the probability of windy and what is the probability of cloudy? What is the probability of windy here? See the windy table. What is the probability of windy? A probability table window oda probability என்னன்னு கேக்குறேன்.
0.001.
அதே மாதிரி cloudyக்கு என்ன வேல்யூ?
0.002.
அவ்வளவுதான். இது ரெண்டுத்தையும் ஜாயின் பண்ணா எனக்கு என்னது அது? அதுக்கு பேர் என்னது? இதுக்கு பேர் என்னது? ஜாயிண்ட் ப்ராபபிலிட்டிங்கிற இதுதான். இது கண்டிஷனல் ப்ராபபிலிட்டி கரெக்டா? இது என்னது?
ஜாயிண்ட் ப்ராபபிலிட்டி.
அவ்வளவுதான். ஓகே, இப்போ இங்க ஒரு கண்டிஷனல் ப்ராபபிலிட்டி இருக்கு. இந்த ஜாயிண்ட் ப்ராபபிலிட்டியை நான் ஒரு கண்டிஷன் அண்ட் ஒரு ஜாயிண்ட் வச்சு கொடுக்கறேன். ஓகேவா? புரிஞ்சுதா? கிளியர்? எஸ் ஆர் நோ? ஓகே, சரி, திருப்பி அடுத்த ப்ராபபிலிட்டி நான் கால்குலேட் பண்றேன். Now you calculate the probability of these two. Here one condition is there and one joint is there. Let's see what it is. What is the condition of the rain when there is no wind, no cloud? See the table. When there is no wind, no cloud, what is the probability of getting rain? என்ன probability?
0.001.
0.001. Okay, 0.001 into I have to get the joint probability of not windy and not cloudy. No wind, no cloud க்கு probability என்ன? See here listen carefully. Here the probability of wind is given. Then the probability of not wind, how I will be calculating? I have to calculate it as
1 minus probability of wind.
0.001.
1 minus probability of wind. Therefore 1 minus 0.001. What is the probability? 0.0. சொல்லுமா, என்ன probability? 0.999. எஸ் ஆர் நோ? ஆமா தானே? என்ன ப்ராபபிலிட்டின்னு கேக்குறேன் நானு. ஒண்ணுல இருந்து 0.001 மைனஸ் பண்ணா எனக்கு என்ன கிடைக்கும்?
0.999.
0.999. Then what is the probability of not cloudy?
0.998.
அப்பா, 0.998. ஓகேவா? 1 minus 0.002 is 0.998. இப்ப இதுதான் ஜாயிண்ட் ப்ராபபிலிட்டிங்கிற நானு. புரியுதா? இப்ப விண்டையும் கிளவுடையும் நான் வந்து ஒன்னா மல்டிப்ளை பண்ணா அது ஜாயிண்ட் ப்ராபபிலிட்டி. இந்த டேபிள்ல இருந்து ஸ்ட்ரெயிட்டா வந்து நாட் விண்டி நாட் கிளவுடி அதை நான் எடுக்கிறேன்னா அதுக்கு பேர் என்னது? கண்டிஷனல் ப்ராபபிலிட்டி. புரியுதா? ஐயே, என்ன பசங்களா?
Understood, ma'am.
என்ன இன்னைக்கு எல்லாம் தூங்கிட்டே இருக்கீங்க? என்ன விஷயம்? முதல்ல எழுந்துருங்க எல்லாரும். All of you type yes in the chat box. For those people only I am going to give attendance today. Yes type பண்றவங்களுக்கு மட்டும் தான் இன்னைக்கு attendance. Let's see how many people are live. So only 15. What about remaining? Remaining are sleeping? Okay, only for this 15 I'm going to give the attendance today. Okay, fine. Now you see, Now tell me what is the joint probability of not W and not C? Not W can calculate panino. Not windy is what probability in
0.9.
0.999. So it is 0.999 into this probability we have calculated as 0.998. Amma dane? Amma vajliya.
Yes, ma'am.
Plus. What is the probability of rain? It is 0.95. I'm going to calculate for this one. Okay. 0.95 into what is the probability of windy and what is the probability of cloudy? Not windy. Okay. Sorry. This is 0.95. Okay. W bar. 0.95 into. Is it 0.95 ma? Not wind and not cloud. Sorry, not wind and cloud. See the table. Not wind and it is cloud. False true condition enna? See the probability table of rain. What is
0.29.
0.29.
0.29. அப்பா எல்லாம் முடிச்சுக்கிட்டீங்களா? சந்தோஷம். Now it is 0.29 into what is the probability of not wind and cloud? Not wind ku probability enna?
999.
Okay, 0.999. 0.999 into இங்க என்ன எடுத்திருக்கீங்க? cloud
0.002.
கொடுத்திருக்காங்க. cloud-க்கோட probability 0.002 plus what is the probability of the rain when it is windy and not cloudy? When it is windy, not cloudy, what is the probability?
0.95.
0.95. So the conditional probability gives me 0.95 into what is the joint probability of wind and not cloud? What is the probability of wind?
0.001.
Okay, 0.001. Sorry. Into what is the not cloud probability?
0.998.
0.998. Okay.
So
0.998.
001 ma'am.
எதுடா இதுக்கு ஆன்சரா ஃபுல்
இல்ல இல்ல மேம் அந்த 0.95 into 00.
ஓகேடா கரெக்ட்டா
Yes,
right.
ma'am.
Now you multiply all these things together and give me what is the output, the probability of getting rain. What is the probability of getting rain, ma? How many of you got the answer? அந்த சாட்டர்டேல கிளாஸ் எடுக்கிறது ரொம்ப கஷ்டமா இருக்குப்பா. எல்லாம் தூங்கி போய் காலையில எந்திரிக்கிறீங்க கரெக்டா 9:30 மணிக்கு. Yogita, tell me the answer.
I'm still calculating.
Okay. கூகுள்ல ஒரு கால்குலேட்டர் எடுத்து இல்ல மொபைல்ல கால்குலேட்டர் எடுத்து போடுறதுக்கு எவ்வளவு நேரம் ஆகும் புது பசங்களா? Just full multiplication and just adding, right? இந்த ஃபார்முலா புரிஞ்சுதா? ஜீரோ பாயிண்ட்
0.00152.
152 வாடா? கொஞ்சம் கரெக்டா செக் பண்ணுங்க.
Ma'am, I got 0.000167, ma'am.
உனக்கு என்னடா கிடைச்சது யோகிதா?
1.5.
Point
0.00152.
152. Okay. Anyone got any other answer?
Ma'am, 252.
Okay, 0.00252 amma.
Yes, ma'am.
252. Anybody?
Ma'am, same answer.
0.00
252.
0.00252. Wait a moment. Board got stuck. Able to see my board? Able to see?
No, ma'am.
No. Wait, I'm coming back. I'm just logging out and coming back. Now it is okay?
Yes, ma'am.
Okay. So again, one more person got 0.00252. Anybody else? Got any other different answer? Same number but different answers. Okay. My answer is 0.00252. Sai Shri family. Sai Shri. Sai Shri. They are in line. 0.00252. Okay. So all got 0.00252. Shivani and Yogita.
Ma'am, when I calculated separately and added, I got that one, ma'am. But all together, when I did, I got 252.
Oh. Okay, fine. So this is the actually the answer is 0.00252. Check it out. So the method what you have to use is you have to multiply everything together. Okay? Okay, ma. தனித்தனியா போட்டு பண்ணாதீங்க இப்படி பண்ணிடுங்க.
Okay, ma'am.
So now in the given original formula we have calculated the probability of getting rain. Now we need to calculate what is the probability of not getting rain. What is the probability for not getting rain? Come on, tell me. The probability. Yes.
0.99748.
Yes. Probability of not getting rain. Okay, that can be given like this. It is 1 minus 0.00256. What is answer?
99748.
9974. Okay, 7444 ல வரும் 6 இருக்கனால இங்க 44. Okay. Yes. 748 வருது. Okay.
252 no ma'am. 256.
6 போட்டணும் நானு.
Yes.
252. Okay. So 0.00252. So it is 8. So the probability of not getting rain is this 0.99748. So you can say here the answer is 0.95 into 0.00252 plus 0.05 into 0.0 sorry 0. 99742. Come on, multiply and tell me the answer. The probability of getting wet grass. What is the answer, ma? Nagadesh?
Calculating.
தப்பான கூட ஆன்சர் சொல்லுங்கப்பா. அப்பதான் கால்குலேட்டரை எப்படி யூஸ் பண்ணணும்னு நான் சொல்ல முடியும். இப்ப பாருங்க, அவங்க யோகிதா அண்ட் சிவானி வந்து they have calculated them separately and then they have given one answer. So it should coincide with the answer given by what Camber. அவர் கொடுத்ததோட நம்ம கோயின்சைட் ஆகணும்னா எப்படி யூஸ் பண்றது அந்த கால்குலேஷன் அப்படிங்கிறது பார்க்கணும். ஓகே, அப்ப சொன்னீங்கன்னா எனக்கு கரெக்டா இருக்கும். எப்படி கால்குலேட் பண்ணா கரெக்டா வருதுன்னு நான் சொல்லுவேன். இன்னுமா என்ன 2 வேல்யூ மல்டிப்ளை பண்ணி ஆட் பண்றதுக்கு இவ்வளவு நேரமாடா? What is the probability of getting wet grass? 0.0?
5 2.
5 to 2.
Yes, correct. 522. This is the problem. All of you got this answer? All of you got this
Yes,
answer? Okay, so this is the probability of getting wet rain. Sorry, wet grass. Sorry, wet grass when it is raining and not raining. எனக்கு வெட் கிராஸ் வேணும், மழை பெஞ்சாலும் பெய்யாட்டியும் அப்படின்னா அதுக்கு ப்ராபபிலிட்டி அவங்க கொடுத்துருக்க டேட்டாக்கு இதுதான். ஸோ இன் திஸ் கேஸ் த நெய்பேசியன் கிளாசிஃபிகேஷன் வில் ஃபெயில் பிகாஸ் இட் இஸ் டிபெண்டிங் ஆன் லாட்ஸ் ஆஃப் ஃபேக்டர்ஸ், விண்டு, கிளவுடு, அந்த மாதிரி நிறைய ஃபேக்டர் டிபெண்ட் பண்ணியிருக்கு. அதனால இந்த நெய்பேசியன் கிளாசிஃபிகேஷன் இதுல கரெக்டாக ஒர்க் ஆகாது. So in those cases, we can go for this Bayesian belief network. We are just believing that when it is raining or not raining, I will get wet grass. So in the belief irukradnalda in the acyclic graph we are just saying that it is what the Bayesian belief network appdin solrom. We are having the belief on it. In the conditional probabilities which I'll get some answers appdin or belief irukku indha edathila. That is why this network is termed as Bayesian belief network. Clear with this? Clear or not? புரிஞ்சுதா? ஏதா சொல்லு.
Understood, ma'am.
Okay, listen, some people normally இப்போ நம்மளோட புக்ல எப்படி கொடுத்திருக்காங்கன்னா we are just calculating the probability of rain and the total probability ல இருந்து we are just subtracting for not getting rain. Even for the not getting rain also they are calculating using this formula. இந்த formula வச்சு calculate பண்றாங்க. In such cases, what will be the modification you will be doing in this formula? Can anyone say? The probability of not getting rain. A minor modification in this formula. Probability of not getting rain. The
Change
formula
R to R bar.
Yes, change R to R bar, that's all. Therefore, this value in the 0.95, the 0.001, 0.95, the 0.29 will become what?
1 minus.
1 minus, that's all. Okay, so 1 minus la போட்டு அதை ட்ரை பண்ணி பாரு. Or you getting this answer called as 0.99748 அது வருதா அப்படின்னு செக் பண்ணி பாருங்க. Definitely it will come. Okay, right? The modification is clear.
Yes, ma'am.
இந்த conditional
Yes, ma'am.
probability ல மட்டும் தான் நம்ம r க்கு பதில் r bar போட்டு போறோம். அப்ப r bar போடும்போது என்ன பண்ணணும்? Instead of 0.95 you will be using 1 minus 0.95, 1 minus 0.001. That value will be using. Okay, right? Clear or not? Say yes or no. புரிஞ்சுதா?
Yes, ma'am.
Yes, ma'am.
ஃபைன்ரா. இதுக்கு மேல actually I thought of saying you what is adaptive probabilistic network classification by using back propagation and all, but today all are sleeping. Okay, I'll say what is this adaptive probabilistic network alone. So adaptive probabilistic network, not only this adaptive probabilistic network, a method called as gradient strategy is available. Okay, so normally this gradient strategy is we'll set some random probability value for a particular node. Okay, in those cases, each and every time I'll move to a proper solution. Okay, proper solution where it will reach to a local optimum solution. Local optimum in the sense it may be either maxima or it will be minima. Okay, or a density function எடுத்துக்கிறீங்க. So this is actually called as, so if you reach this particular point, when you iterate from here to here, I'll take one random value. Or a random value I'll be taking from here. And each and every time, the same function will be modified and modified by using a new value. In one particular place, the function will reach to this zero. Okay, and the particular value then என்னன்னு சொல்ல local minima. Suppose my probability function is working like this. I'll start from a random value in this place and I'll reach to this particular maximum value. This is called as a local maximum. Local minima, local maxima அப்படின்னு நம்ம படிச்சிருப்போம். அது ஒண்ணும் இல்ல, ஒரு மேக்ஸிமம் வேல்யூ அந்த ஃபங்க்ஷன் ஒரு பர்டிகுலர் பாயிண்ட்ல ரீச் ஆகும். அதுதான் என்னன்னா லோக்கல் மேக்ஸிமம்னு சொல்லுவோம். அது மாதிரி இந்த ஃபங்க்ஷன் என்ன ஆகும்னா ஒரு பர்டிகுலர் பாயிண்ட்ல ஒரு லோக்கல் மினிமம் வேல்யூ ரீச் ஆகும். அது பாயிண்ட் வி ஹாவ் டு நோட்டீஸ். அப்போ அந்த பர்டிகுலர் டைம்ல தான் திஸ் இஸ் ஒர்க்கிங். அந்த வெயிட்டை நம்ம நோட் பண்ணிட்டு அதுதான் லோக்கல் மினிமம் லோக்கல் மேக்ஸிமம்னு ஒரு கரெக்டான பார்டர் ஃபிக்ஸ் பண்ணிட்டு அண்ட் தென் வி வில் ப்ரொசீட் வித் ப்ராப்பர் ப்ராபபிலிட்டி வேல்யூ. So this is called as a gradient strategy. So in each iteration, the algorithm will be moving towards a best solution, and then the weight or the probability value will be adjusted accordingly. So this is considered as, if this strategy is used in case of this probabilistic network, then it is called as a adaptive probabilistic networks. So the method what we are using is called as a gradient strategy. இதை வச்சு நான் ப்ராப்ளம் அப்புறம் ஒர்க் அவுட் பண்றேன். Okay, so in this cases we are not at all moving back and we are just adjusting the backward solutions. We are just moving forward. But if you turn back, that is we are just going back and we are adjusting the solution, then it is considered as back propagation. So if that back propagation is used in case of the classification technique, then that is called as a classification by back propagation technique. சொல்றது புரியுதா? இந்த இடத்துல நான் ஏதோ ரேண்டம் வேரியபிள், இது என்னோட கிளாஸ் லேபிள்னே வச்சுக்கோங்களேன். இந்த லேபிளுக்கு ஒரு இது டிபெண்ட் பண்ற அந்த அட்ரிபியூட் ஃபேக்டர்ஸ்க்குலாம் ஒரு ப்ராபபிலிட்டி வேல்யூ கொடுக்குறேன் நான். அந்த ப்ராபபிலிட்டியை பேஸ் பண்ணி அந்த ஃபங்க்ஷனை அட்ஜஸ்ட் பண்ணி ஒர்க் பண்ணிட்டே வரேன். ஒர்க் பண்ணிட்டே வரும்போது என்னோட எய்ம் வந்து மேக்ஸிமமா இருந்ததுன்னா the probability function will work in the increasing manner. When my solution is for the minimum value, I'll work in the decreasing manner. அப்படி ஒர்க் பண்ணிட்டே வரும்போது எந்த இடத்துல எனக்கு அந்த லோக்கல் மினிமா அண்ட் லோக்கல் மேக்ஸிமா ரீச் ஆகுதோ அந்த பாயிண்ட்டை நான் நோட் பண்ணிட்டு அதுல இருந்து கரெக்டான ப்ராபபிலிட்டி, தட் இஸ் கரெக்டான வெயிட் ஐ வில் பி ஃபைண்டிங் அவுட். ஸோ ப்ராப்பரா இந்த வேல்யூ ரீச் ஆகும்போது எனக்கு இட் வில் ரெயின், இந்த வேல்யூ ரீச் ஆகும்போது இட் ஓன்ட் ரெயின், இந்த வேல்யூ ரீச் ஆகும்போது I'll take off or else I won't take off. So that decision can be given by this adaptive probability. Then without backtracking, then it is considered as adaptive probabilistic networks. So when you backtrack and adjust the weight, adjust the probability, then it is considered as back propagation னு சொல்றான். அதை யூஸ் பண்ணி என்னோட டேட்டாவை கிளாசிஃபை பண்ணா அதுக்கு பேர் என்னது? கிளாசிஃபிகேஷன் பை பேக் ப்ராபகேஷன். ஓகே, லெட்ஸ் ஒர்க். இன்னொரு கிளாஸ்ல நான் பேக் ப்ராபகேஷன் ஒர்க் பண்ணி காட்டுறேன். ஓகே, ரைட்? ஓகேவா? ஸ்டாப் பண்ணிடுவோமா?